We're going to start with chapter 6, which is on factoring. Now, I imagine that you remember from some other moment in your life talking about factoring. When you're factoring, you are finding things that can be multiplied together to get a particular value. If I ask you to factor the number 6, well, some of you might say, well, 6 is the same as 6 times 1. Somebody else might say, well, I was thinking 6 was the same as 3 times 2. Those are both sets of factors. The second set is a set of prime factors. These are prime factors because, remember the definition of the word prime. A prime number can only be factored as itself in 1. How can you get 3? There's only one way. 3 times 1. 2, there's only one way to get 2. 2 times 1. This is the prime factorization of 6. Now, you're not going to need to do prime factors of numbers in here. You're going to be finding prime factors of polynomials. So we'll be moving into talking about factoring polynomials. And some of you, it's been a little while, and you're thinking, what is a polynomial, this thing that I'm about to start factoring? Let me give you an example because I think that'll be the best way to jog your memory. If you had 5x squared plus 3x minus 7, that is a polynomial. It is specifically a polynomial. It is a sum and difference of terms. This one has how many terms? 3 terms. And what do you call a polynomial with 3 terms? A trinomial. So this one is specifically a trinomial. And don't worry if you're a little rusty on some of the language, I'll mention it as we go along. If you wanted to read about polynomials, you could go back to section 5.1. Okay, chapter 5 was on polynomials, so you could go back. All right, we're going to learn how to factor these. We're going to learn blank times blank gives me 5x squared plus 3x minus 7. Okay, that's where we're headed. We will study every section of chapter 6, and each section gives us some techniques for factoring. Section 6.1 gives us 2 techniques. GCF stands for the greatest common factor. Greatest common factor. This is a factoring technique that is going to be used over and over again. It is a technique for finding a way to take a polynomial and break it so that it is something times something else. Okay? Greatest common factor. You notice that there was a second title. It was grouping, and we'll do that in just a little bit. Okay? So, greatest common factor. Greatest, of course, means large, largest. Common means something that is in more than one thing. And a factor is something that's multiplied together to get our polynomial. So I'm going to go to the My Math Lab notes. These are the notes to print, which, of course, you didn't have the option to do. But let's look at problem number 1. The instructions. The instructions, I'm not going to write them down every time. But it says to factor out the greatest common factor. So all of these are about factoring the GCF. All right, problem number 1. They give me the polynomial 5x plus 30. To find the greatest common factor, it's going to feel a lot like how you felt when you were reducing fractions because you were finding a GCF then. Can you think of a number that goes into 5 and into 30?
6.
Okay, now the 6 is something that's going to be left over. What is it that actually divides into them? The 5. The 5. Okay, so the 6 I will get though. All right, so 5 is the greatest common factor. So I'm going to write it down. You notice I've left a little space because of the way I do this. If you factor the 5 out, what you're doing when you factor something out is you're dividing it out. You don't need to show that if you don't want to, but that's what I'm doing. Now, how many times does 5 go into 5x? It goes, the coefficient will be a 1 and the x will be left over. I don't write the 1, I'll just write x. So some of you might have said, yeah, I was going to do that. I was going to mark those 5s out because they, quote, canceled out. When something cancels out, a 1 is really left behind. Okay, now for the next part, how many times does 5 go into positive 30? 6 times. Those are your factors. One of them is the number 5, and the other one is the binomial x plus 6. How could you check it if you wanted to check it? Use the distributive property. You use some kind of multiplication to check your factoring. So if I had 5 times x plus 6 and I was going to check it, I would use my distributive property. 5 times x would give me 5x. 5 times 6 would give me 30. And is that the polynomial I started with? Yes. So I feel okay about it. Okay, so you can check these. So let's do a couple more that are like this. Number 2. What if I have 8x minus 4? What's the greatest common factor of each term of this binomial? 4. So if I factor the 4 out, and if you want to, you can write it down that you're dividing by it. 4 goes into 8x, 2x times. Well, what do I put over here? What should I do? I have 4 over 4. That's 1, yes. So that's where you want to be careful. If you use the phrase, cancel out. Cancel out usually implies everything's gone and you have a 0. Everything's not gone. When you divided those out, you had little 1s left behind. And so you don't want to lose those. Yes, ma'am. Question? All right, I'm going to talk about what if you looked at this and you said, well, I didn't get a common factor of 4. I got a common factor of 2. Okay? If you factored out the 2, do you agree that 2 will go into 8x 4x times? And 2 will go into 4 2 times. Now, here's the problem I have with that as an answer. Is 2 the greatest common factor? No. Did she get a common factor? Yes. But did she get the greatest common factor? You could say no because look at these. Do these numbers still have something in common? There's still a 2. So if you did it this way, you would keep this 2. You would see that there's still a 2. So there's another 2. Factor it out, and you'd get 2x minus 1. Do we now have the same answer? You want the number out here to be the greatest or largest. It can be misleading because look at the answer right here. I would mark it wrong if my instructions had said factor this completely. But if you checked it, would it appear to you that you had done it right? Because what's 2 times 4x? 8x. What's 2 times negative 2? Negative 4. You would appear that you had it right because you do have factors, but you didn't have the greatest common factor. Okay, so you want to watch out for that. I wrote watch out over there, you can't see it. Okay, so that's a very, very good point. Number 3, I'd like you to do this one. It is simply 39x plus 3. And I would like you to factor out the greatest common factor. What did you see as the greatest common factor between these two terms? 3. So when you factor out a 3, and that means divide it out, you should get 13x plus a 1. And those are your factors. Your first 3 questions in Math Lab should be just like that. Number 4 has you start dealing with variables. Let's suppose I have x to the 5th plus 3x to the 4th. And the instructions are the same. Factor out the greatest common factor. Now, the coefficient of the first term is an implied 1. This one is a 3, but there's no common factor. Is the variable x in common on both of those? Yes. So I am going to take an x out. Now, some people think that about what I'm about to say is confusing, but I hope you won't. Well, there's powers of x. You take the lowest power of x that you see. Now, here's what sounds a little inconsistent. I'm talking about a greatest common factor, and yet I'm telling you to take the lowest power. The reason I say take the lowest, which would be a 4, is that can you factor out or divide out anything more than x to the 4th out of this term? Can I divide an x to the 5th out of that term? No. I can take no more than the lowest power. So I'm going to lowest power of x. Take the lowest power. So x to the 4th is the greatest common factor. Divide by x to the 4th, divide by x to the 4th. Those of you who have very recently had 307, you're going to know exactly what I'm talking about when I say you're about to use the quotient rule for exponents. Because the quotient rule says if you have division, a quotient of like bases, then you subtract the exponents. So it's 5 minus 4, which is x to the implied first power. You notice that I kind of put a little dotted 1 because you really wouldn't write that 1. Plus, what happens in the next term? Do you all agree that the x to the 4th and the x to the 4th divide out? So what are you left with? Just a 3. Mentioning the quotient rule, you would have 3x to the 4 minus 4. What's 4 minus 4? 0. X to the 0 is equal to 1. It may be a while since you did 0 exponents. X to the 0 is 1. It's 3 times 1, which is 3. But the easy thing is, I just marked them out. Is that okay? Those are my factors. All right, let's look at number 5. I have 4x minus 8y plus 4. Greatest common factor. What will go into all of those? How much? 4. Okay. So if I factor out a 4, by the way, did they have a common variable? No. So if I divide 4 out of each of those, I'm going to get x minus 2y plus a 1. If you neglect to put the 1, then it won't check. Let's look at number 6. Suppose I have 16x to the 3rd plus 14x squared minus 10x. Is there a common numerical factor? What will go into 16, 14, and 10? 2. Is there a common variable? X. Can I take anything more than just plain old x to the 1st? No, because that's the low power. You cannot take more than the low power. So I'm going to divide each of these by 2x. That will give me 8x squared plus 7x minus 5. And for those of you who have recently done some factoring, you might be looking at this saying, well, now do I need to do something more? And the answer is no, we're still in 6.1. So all you're looking for is the greatest common factor. All right, number 7, I have 15x to the 3rd plus 6x squared minus 9x. Would you do this one? Factor out the greatest common factor. All right, let's see about going on. What did you see as a numerical common factor between 15, 6, and 9? 3. Did you see a common variable? X. So I need to divide 3x out of all of those. That gives me 5x squared plus 2x minus a 3. And if you got that, then you've got it. Question? Okay.
3x.
Are you talking about this last one?
No, the second one.
This one?
Yeah.
Okay. The 3 goes into the 6 2 times. I have an x to the second over an x. This x has an implied exponent of 1. So I have 2 minus 1 is this 1. Okay? Anything else on that one? Okay. All right, now this last one, this is really going to see if we've got it. This is the last one of just greatest common factor. Get ready, because the writing is intense here. I have a to the 7th, b to the 9th, minus a to the 5th, b to the 4th, plus a to the 4th, b to the 8th, minus a to the 4th, b to the 4th. Did it all get on there? Yeah. Whoop, hello, come back. All right. Is there a numerical common factor to factor out? Is there a number? No. Do all of those terms have a's?
Yeah.
Okay, so I know that an a is part of it. What power of a do I take? 4th. Why? It's the lowest. Okay. Do they all have b's? What power do I take? 4th, because it's the lowest. Now, I have to divide each of these by a to the 4th, b to the 4th, and I am going to use over and over the quotient rule for exponents, which says to subtract the exponents. For the first term, I have a to the 7th over a to the 4th, which will be a to the 3rd. I have b to the 9th over b to the 4th, which will be b to the 5th, minus I have a to the 5th over a to the 4th, which will just give me a, but what happens to the b's? They cancel out or divide out, so it is if I'm saying it's a times 1, which is a. All right, plus, in the next term, the a to the 4ths divide out, so that's a 1 times b to the 8th over b to the 4th is b to the 4th. And for the last term, everything divided out, which means what's left over? 1. Done. Okay, I want to make up a problem that is not going to be in Math Lab, but it's something that I need you to remember. So I'll write that in red. Remember, if the leading term is negative, comma, factor a negative, GCF. And I'm about to show you an example of that. If the leading term is negative, factor out a negative GCF. So if I ask you to factor negative 3x squared plus 12x. First of all, look at it and just tell me what is the common number to both of these terms? A 3. And is there a common variable? X. Okay, so 3x. But because that is a negative sign right there. I'm going to factor out a negative 3x. And that is simply a rule. When the leading term is negative, take out greatest common factor, but make it be negative. So I'm going to divide by negative 3x. Divide by negative 3x. A negative divided by a negative gives me a positive x, and a positive divided by a negative gives me a negative 4. What does that accomplish? Why do they have that rule about the negative leading coefficient causes you to factor out a negative? It is so that the new factor that you created will start with a positive. It is just more acceptable for a leading term to be positive. And by factoring out the negative, it went out here. Okay, you're going to see that come up occasionally. All right, now, there's a second topic in all of this. If I scrolled all the way back up, in the title, it said GCF and grouping. The next couple of, about 3 questions are going to be getting ready for grouping. Each time that I give you one of these titles like greatest common factor or grouping, these are names of techniques that you're going to use to try to factor polynomials. Grouping. It is used when you have 4 terms. Now keep in mind that these first 3 problems are just getting ready problems. All right, problem number 9. And in MATLAB, this is where it will change, just like this has. Suppose I ask you to factor y parentheses x to the 5th plus 7, close parentheses, plus 3 parentheses x to the 5th plus 7. Now this is just a getting ready question. All right, does everybody see this as y times something plus 3 times the same something? Okay, those somethings are little groups of things. I can factor that group out just like I could if it were a number or a letter. And what I would do is I would factor it out. So I'm going to write it down in front. And what will it be left? Well, if I took this one and divided it by x to the 5th plus 7, do you agree that this and this would cancel? And you'd be left with a y. And if I divided into this one, this would go away, and what would you be left with? 3. And I'm done. Remember, what is your goal? Factoring. To change an expression that's got pluses and minuses into a product. And I have turned it into a product. This first one was the common. And the second one is what I call the leftovers. There's my leftovers. Put them together over there. Okay? Let's do another one that's very, very much like that. Number 10. What if I had y parentheses x plus 8 close minus 3 parentheses x plus 8? Do you see the common, what's called the common binomial factor? Do you see it? So write it down, x plus 8. What's the other factor, the leftovers? Y minus 3. How easy is that? Please keep in mind, I called these getting ready problems. I'm not really doing grouping yet. One more. Let's suppose I have r parentheses z to the 7th plus 4 minus parentheses z to the 7th plus 4. And by the way, when I write z's, I cross them so you won't think that they're 2's.
Excuse me, what letter is that?
This is an R. You'll kind of get used to my writing. Okay, do you see a common binomial factor? Okay, so if I factor that out as z to the 7th plus 4, what is the leftover? Excellent. R minus 1. I have to have something here, and since there's nothing written, I believe that there is an implied 1 there. So I have z to the 7th plus 4 is the common factor, and then what's left over is R minus 1. Okay, now we're going to look at full-blown grouping, where we do all of it. So there actually will only be one additional step. What if I had 3x plus 15 plus xy plus 5y? How many terms do you see up there? Altogether. 4 terms. 4 terms. Anytime you see 4 terms, your brain should click grouping. Okay? Now, the grouping. There really are a lot of different ways that you could group these. There's only one way that's the way you should. I should rephrase that. There's only one way I'm going to. It's not a matter of right or wrong. I'm going to group the first 2, and I'm going to group the second 2. And it'll always work. So why make it hard and say, oh, I'd like to take the first one and the last one. Oh, please don't. Just take them as they are. All right. Just focus on the first group. What's in common for this first group? 3. So I'm going to factor out a 3. And 3 will go into 3x x times. And 3 will go into 15 5 times. Okay, I've taken care of the first group. Whatever the sign is, it's going to come straight down. What's in common in the second group? Y. So put it out, and you're going to divide each of those by y, and what are you left with? X plus 5. The problems are rigged. If you do it correctly, I guarantee you every problem in Math Lab, every problem in our book will work out so that you have that common factor. Now, doesn't this look like how problems 9, 10, and 11 all started? Common factor is x plus 5. And what's the leftover factor? 3 plus y. Did you just take a 4-termed polynomial and come up with factors for it? Now, we've not talked about how do you check these. You check these. How do you multiply a binomial times a binomial? FOIL. You check with FOIL. We will review FOIL a good bit tomorrow, so I'm not going to say a lot about it right now, but if I do this by FOIL, product of the first is x times 3, which gives me 3x. Okay? The outer is x times y. There's my xy. It wasn't second, but I still had it. The inner is 5 times 3, 15. There it is. The last is 5 times y, 5y. Did it by FOIL, got all 4 terms. Number 13. It's another problem to solve. The instructions will say factor by grouping. So I have 4x plus 20 plus xy plus 5y. How do I know I'm supposed to use grouping? Well, yeah, the instructions said it, but also it's because I have 4 terms. First group, second group. What's in common in the first group? 4. And if I divide 4 into 4x, I get x. And if I divide 4 into 20, I get 5. Keep the sign. What's in common in the second group?
Y.
Is this the same problem? No, but it's very similar.
Yeah.
Okay, y. And if I divide y into the first one, I get x, and y into the second, I get plus 5. Do you see the common binomial factor? I highlight it in yellow, but you have to be able to see it without that. So the factors will be x plus 5 times 4 plus y. I'm going to skip a few of the problems because it gets a little bit redundant. You have to practice the same thing over and over. And I want to skip in my notes to number 16. And I have 2x squared minus 18xy minus 7x plus 63y. And I want to factor that. How many terms do you see? 4 altogether. So I'm going to do grouping. First group, what's in common? All right, I see a 2. What else? An x. So if it helps you, write that under there. And if you don't need it, that's fine too. 2x goes into 2x squared x times. 2x goes into 18xy minus 9y times. Now, I feel pretty confident that when I work on the second group, I better end up with an x minus 9y. Okay, I better. I just already know that. Do you notice that the sign here is minus? That means I'm going to factor out a negative common factor. But that was my rule earlier. When the leading term of a group, or the leading term of a whole polynomial is negative, factor out a negative factor. So what's in common between these two? 7. So I'm going to divide each of those by negative 7. A negative 7x divided by negative 7 is x. 63y divided by negative 7 is, did I say 63? Anyway, whatever that letter is, 9y. Did it work out right? Yes. And so I call this self-checking. You know if you did it right because those two binomials in the parentheses will turn out to be the same. So what are the factors? X minus 9y times 2x minus 7. And what would you use to check it if you wanted to check it? FOIL. You would use FOIL. And I'm not going to check this one. Now, 17 through 20 are just more practice, nothing new. So I'm not going to take our time to do those. Does anybody in class have a question about, number 1, greatest common factor, number 2, grouping? Uh-huh.
When you do your signs in between,
yes.
when you get to the last stage, you always drop the negative or the positive?
Yes. Yes, and so that it turns into multiplication. Yes, always. Okay, then I'm going to stop this.